Hello dear students, let's see how to construct pushdown automata for language. So let's see construction of PDA for the language A raised to n, B raised to n such that n is greater than or equal to 1. We already had an idea about what is to be accepted and what is to be rejected, correct? Now, as you all know, PDA has set of states. And let's say Q0 is the initial state of the PDA. Now, here is the input tape that we are having, and let's imagine that the input is AA followed by epsilon, and we are about to read A. And this is the stack, and stack, as you all know, contains initial symbol Z0. Now, as we have seen the configuration of PDA, PDA works on a triplet. That means PDA tries to understand what are three things. The three things are current input. What is it reading right now? Current input is A, correct? And current state, in which state the PDA is at the moment? It is in Q0. And current top symbol of the stack. The current top symbol is Z0. These three things is what PDA will always check. And this is shown in our configuration as we say Q0, check my words, Q0 is reading A. Q0 is reading A, and at that point of time, top is Z0. We write this as Q0 is reading A and top is Z0. All three things have appeared here: current state, current input, and current top. Then what is the idea is we are going to, for this X, we are going to push X on the top of Z0. Then we just write slash in our notation, in our diagram, and we say that Z0 will be preserved as it is, but on top of this, we will push X. You watch how Z0 is now superseded by X. X is on top of Z0. You can see this is the result of a push operation. And the plan is that we will keep ourselves in Q0 state. What that means is when Q0 reads A and top is Z0, then it results in the same state Q0. We are not moving anywhere, but Z0 is superseded by X. What is the new configuration? After reading this first A, top was Z0, but now top is X, correct? And the state of the machine is still Q0. We are still in the initial state. I hope you are understanding. So what have you read till now? First A was read. Now we are about to read second A. Second A we are about to read. And what is the condition of the stack? We have Z0, on top of that we have X. And in which state are we right now working? We are still in Q0. What happened was, in this Q0 we read first A, but at that time top was Z0. Then we just pushed X on top of Z0. Now have a look at this. What is the current input? Current input is A. This one current input is A. What is the current state? Current state is Q0. But what is the current top of the stack? It is X. Last time the current top was Z0, but now the top is X. So you got a new configuration, right? And what is your plan? If you read A, then you will be pushing X. But how do you define this? You define this as we will stay in Q0, same state we will stay, and if we read A and the top is X, check the configuration. In Q0, if you are reading A but top is X, then slash, check the convention, we will keep that X as it is, but we'll push one more X on top of it. We are pushing one more X on top of X. This results in B in Q0, preserve the previous X, but push one more X on the top. Why we are staying in Q0? I think this must be apparent. This you might have understood, because we are giving responsibility to Q0 state to handle all A's. That's a good idea. We are saying Q0, you keep reading A's, And whenever you read A, you be in Q0 itself, but keep pushing X. And note we have got two configurations. Are you understanding? Q0, A, Z0. This configuration means this is the first A that we encountered at the beginning of the input, because at that point of time stack is Z0. But this is consecutive A. Consecutive A. It is not the first A because stack is already containing X. That means before this A, there was an A encountered, right? So now, what are you now having? Just check. Now, you have already read two A's. Now, you are about to read B, correct? First B. And the stack is having Z0 and 2X on the top. And the machine that we have constructed till now is, we say, if Q0, if you read the very first A, that means top is Z0, then preserve it and push X. And we tell Q0 that if you read consecutive A, that is X is already there, then push one more X. Now what if you read B? The plan is, if you read B, you are going to pop X. You know it already. If you are reading B, you will pop X. But the good idea is, why don't we give another state Q1 to handle all these B's? So on reading B, it's a good idea to change the state so that we can create a loop here for B. But then what is the configuration? When you are reading a B, in Q0, just check, Q0 is reading a B. Yes, we are still in Q0 state and Q0 is reading first B. At that point of time, what should be top of stack? Just check my words, top of stack has to be X. Check, I will pinpoint, I will press on this point. When you are reading a B, top of the stack has to be X. It can't be anything else. It can't be Z0. If you are reading a B, tell me, shouldn't there be a pending? Come on. You should have some X on the stack. That means we will say Q0, when you are reading a B and top is X, then what are you going to do? You are going to remove this X. This is shown as epsilon. What it means is, you are just replacing this X with epsilon, and epsilon means nothing. That means you have popped one value and you have changed to Q1. So how will you show this? In Q0 state, when you read first B, top has to be X, and you will move to Q1, and epsilon is now the result. That means X has been replaced with epsilon. This is the pop operation, correct? Now the machine is in Q1. What Q1 will do, it will keep reading next B. Let's see what happens now. What are we now having? We have read two A's and one B. Now we are about to read the second B followed by epsilon. This is the B we are reading, and the stack is now having Z0 followed by Z0 followed by X. One X has been popped, and the machine that we are having till now is Q0, which was reading very first A, top was Z0, then Z0 was preserved, X was pushed. This was for first A. When Q0 was reading A, top was X. This was consecutive A. Then we pushed one more X. But when Q0 read the very first B, top has to be X, and we popped it. Now in Q1, we say Q1, if you get a B, just check if Q1 is getting a B, what should be, I'm so sorry, Q1 is getting a B, then what should be top of the stack? Please try to understand, if machine reads B, then there has to be a pending. That means there must be X on the top. So we'll say B, if B is read, top should be X, and we'll pop it. We will simply pop this. What that means is Q1 reading a B, top is X, then this results in Q1 state itself with epsilon. So we have replaced X with epsilon again. I hope this is understood. So now what? Now, which is the next symbol that will be read? B is already done. Next symbol read will be epsilon. Just see, this X also has been popped. And now epsilon is getting read. But which state is reading epsilon? Yes, Q1 is reading epsilon. And we will then say Q1, if you have nothing yet to read, then what should be the top of the stack? Top of the stack has to be Z0. Please try to understand. If the machine reads epsilon, In Q1 state, top must be Z0. That means tally has been done. And we will, what is the idea is, we'll keep this Z0 as Z0. We will not make any change to the stack, and we will go to Q2, which is the final state. This is the resultant PDA, pushdown automata, which was constructed by us by thorough discussion. You see, Q0 is the accepting state. Let's very quickly see the working of this PDA. Okay, but of course, I am sure that you have understood the working, but give me an opportunity. Just see that I will go through this entire working again, and I will show how a string is accepted, how is it rejected by PDA at various steps. Okay, so this is exactly the PDA that we have constructed. On reading epsilon, if top is Z0, we will keep it as Z0, and Q2 is the final state. Take a input such as A double B. You know this should be rejected. Okay, draw the stack. Okay, and initially Z0 is the top. Now input is A, check. Q0 is the initial state. Input is A, top is Z0. What are we going to do? Push X. So X got pushed, and we are still in Q0 state due to this loop. Now continue reading B. Okay, now Q0 is reading a B. Q0 is reading a B. Then top has to be X. Very good. Top is X. Then we will pop that X out of the stack, but we will enter Q1 state. So now the new state in which the machine is Q1, but the machine is now going to read next B. Now you just check, if Q1 is reading a B, then top has to be X, we have said. Please try to understand, when the machine is reading this B, the top must be X. But what is the top? Z0. But you have not defined any such configuration. What configuration? Which configuration you are not defined? You are not defined what should Q1 do if it reads B and top is Z0. You have purposely not defined it, because Z0 was not expected when you are reading B. When you are reading B, always the top expected was X. But there is no such configuration where machine knows what to do if B is read and top is Z0. Observe, you will never ever observe any such triplet, because you are not defined it. Then machine says, I don't know what to do when I am in Q1 and when I am reading B and top is Z0. I don't know. So I will halt here. Machine halts. Simply because there is no such configuration declared. See, the configuration that we have declared is Q1 B X. Check this. Q1 B X. This is the configuration. What it means is, you need an X. You need that symbol X on the stack when you are reading a B. You cannot expect Z0, but now you have top as Z0. That means the string will be rejected, because the machine halts in Q1 and Q1 is non-final state. As Q1 is non-final state, machine halts. Machine halts in non-final state. So we'll say this input is invalid. I hope you have understood. Let's take one more run of this machine. Give me some time. Just see, if we take the input like this, just check. If we take the input as double A double B and then the epsilon, this is the input. Now, what is the stack initially? That's Z0, and we are in the initial state to begin with. Now, what is the configuration? We are reading A, we are in Q0, and top is Z0. Observe. So we have Q0, A, Z0. This is first A. Then we said that we will be pushing X and we will stay in Q0. So still in Q0, but top is X. Now, when you are reading the second A, this configuration will be used. We are still in Q0 and you are reading A, but top is X. Then we will push one more X, as you see. Now, and we are still in Q0, remember. Now, when you are reading the B, in Q0 state, you are reading a B, correct? you are reading the first B in your input, then top must be X. You observe this, and top is X. Then we will pop this X and we will enter a new state Q1. Now the state in which the machine is Q1. Now we are reading this B now. In Q1, when you are reading a B, observe top has to be X and we have an X. That means for this B that we are reading, we have a matching X. And we are going to pop this also because of this epsilon. And we will stay in Q1. Now, when we are reading the last epsilon, this one, then in Q1, we are reading an epsilon. That means the input is over. If the input is over, top has to be Z0. Please try to understand, and it is Z0. Then a good idea is don't do any change in the stack. Okay, if Z0 is there, keep it as Z0. We don't want to push, neither we want to pop, because the tally has been done. Everything has been accounted properly. Then we will keep Z0 as Z0. No change in the stack, but we will enter the final state. Just check, final state will be reached only if number of A's are equal to number of B's. That too, A is in the front and B is at the tail. I hope you have understood development of this PDA, and it will be great fun to see more examples like this in the coming videos. Thank you very much.